Here's another example, and the wording's a little bit different of the directions. So find f if you're given f prime. So that means you're just finding the antiderivative. We have a function that we're going to use. First find the general antiderivative on, and then we're going to plug in the value of x equals 4 to solve for this constant. So the antiderivative of 1 plus 3x to the 1/2, I replace 1 with x. I add 1 to my power of 1/2 to get 3/2, and then divide by 3/2, and I tack on that c. Simplify. This is my general antiderivative. Now I evaluate it at x equals 4, set it equal to 25, and solve for c, and I get c equals 5. So therefore this is my particular antiderivative. Here's another example. Notice we're given the second derivative. We're supposed to find f. So now in this case we're going to have two arbitrary constants because we're going to have to find two antiderivatives. And so if that's the case, you have to have two conditions to solve for each of those constants. So that's why we're given f of 0 equals 3 and f prime of 0 equals 4. These are called initial conditions because this is x equals 0. So to find f prime of theta, I need to take the of f of theta, I need to take the antiderivative of f double prime. So again, what function's derivative is sine theta? Well, that's minus cosine theta. What function's derivative is cosine theta? That's sine theta. And then I add on that arbitrary constant. I'm going to call it C1. So it's given that f prime of 0 is 4, so I can solve for C1 now. And when I evaluate f prime of theta at 0 and solve for C1, I get 5. So this is f prime of theta, but I want to find f, so I need to find the antiderivative of this. Again, what function has a derivative of minus cosine theta? That's minus sine theta. What function has a derivative of sine theta? Minus cosine theta. And then this is my constant 5, and that's antiderivative is going to be 5 theta. And I add my other constant. And so now to find the value of C2, I'm going to use this initial f of 0 equals 3. I evaluate my general antiderivative at 0, and I get C2 equals 4. So this is my function f. Another example, given another problem given another way, the directions are given another way. Given the graph, that the graph of f passes through this point 2,5, and that the slope of its tangent line at any point is 3 minus 4x, find f of 1. So we're being told that the derivative function is 3 minus 4x. So we want to find a particular antiderivative because we're also told that the function passes through the point 2,5. So in functional notation, that's what we're being given. So we find a general antiderivative of 3 minus 4x. That would be 3x minus 4x squared over 2 plus c. And I simplify that. And then I'm going to solve for c using the 0.25. So c is 7. And this is my function, but I'm being asked to find f of 1. So I evaluate that at 1, and I get 8. Here's another example where we are supposed to make a rough sketch of the antiderivative function given a function. So we've actually seen problems like this before in the past when we were sketching derivatives. So this function is actually the derivative of this capital F function that we're looking for. So this is really a rehash of what we learned about earlier. So since this is the derivative of capital F, that means that f prime of x equals lowercase f, which is given in this graph. So what do we know about f based on its derivative? Well, we look at where lowercase f is less than 0, and that's where capital F is decreasing. We look at where it's greater than 0, and that's where capital F is increasing. We see that where capital F has max and mins by the zeros of lowercase f. We see where capital F has inflection points or changes concavity based on the max and mins of our derivative. And we see that the derivative here, it looks like it goes to 0. So capital F is going to have a horizontal asymptote as x goes to infinity. So again, we've seen things like this before. You mark the max and mins, you mark your inflection points, and then you try to, sketch your graph. When you make these graphs, I find it easier to start from the inflection points and graph outward than like starting from one end of the graph and then trying to get the curvature right through the inflection points. But this is not a big portion of this section, so we've already done those things. So the last topic in this section is rectilinear motion. So we've seen that before. So remember that for a position function, its derivative is the velocity, and its second derivative is the acceleration of the object. So we are going to, if you're given the acceleration function, you can find the velocity by finding its antiderivative. And likewise, you can find the position function by finding the antiderivative of the velocity. We're given that a of t is 10 sine t plus 3 cosine t, and we're given these. So notice that both of these conditions are for s. So I'm given the acceleration, the velocity, by finding the antiderivative. So I take the antiderivative of my acceleration function, again thinking what function's derivative is sine t? Well, that's minus cosine t. What function's derivative is cosine t? That's sine t. And then I add my arbitrary constant. And notice I can't solve for that yet because my conditions are in terms of s. So now I want to find the antiderivative of the velocity to get the position. So I take the antiderivative of that velocity function I just found. And again, I'm not going to talk through the sine and the cosine step, but this step, c1's just a constant. So its antiderivative is just simply c1 times t. And again, I add on an arbitrary constant for this antidifferentiation step to find s. So now I'm going to find c1 and c2 from these two conditions I was given. So s of 0 gives me that c2 equals 3, and s of 2 pi gives me that c1 equals 6 over pi. So this is my position function. So in summary, we are performing differentiation in reverse. And when you look at a function and you're told to find its antiderivative, it can be worded a few different ways. So remember that there's two types. There's a general antiderivative where you need to add on that constant c, and that is a common thing to forget in WebAssign, and that can get you marked wrong. And then we can find a particular antiderivative, but we have to be given conditions in addition to just the function.